This is another little project I'm working on here in my basement shop. This would be a bus voltage regulator, typical of the type voltage regulator that comes in the 50DN series alternators. This would be the 12-volt version. So as far as I know, these units work with all of the 12 and 24 volt alternators in the older buses. You'll recognize these. This one's apart, but you can see the model I'm talking about. So what happens is the two solid state components fail. This is a little signaling regulator. This is the small little black transistor that you see soldered to the printed circuit board. These parts are available, and I'll get you that information later. This is the small one. I have that propped in here on the board. You can barely see it right here. See the little... So now we begin with the preheated soldering gun. Be sure the tip is nice and clean. I use an emery board to scrape the junk off the tip. As these tips get hot, they begin to corrode. So clean the tip real good. And remember, I told you before, using electrical solder, the rosin core solder, 60-40. Do not use lead-free. Do not use silver solder. Do not use plumbing solder. This is a rosin core solder. Okay, let's give it a shot here. And I believe the camera is still aimed right. And as quickly as you can, apply heat and solder. Make it quick and get right off. Now you can remove the heat sink and take a look at what you've done. And as you can see, as you cannot see, maybe you can see. You see I got solder on that? Now I'm going to solder the other two. By the way, be sure that the leads aren't too long so that the component sticks up above the profile of the other components. I forgot the heat sink. I guess for the sake of simplicity, I'll move this plate out of the way for now. And now I'm going to put this on terminal number 1. Terminal number 1 is the emitter. This device is made up of emitter, base, and collector. 1, 2, 3. So now with the heat sink on that terminal, I'll solder it. And again, be quick and be accurate. If you're shaky, take a tranquilizer first. So that your soldered connection, you see? Okay, I'm back. So now I'll give you a better, got some light on this subject. You can see the little solid state component, the little come on camera, focus. There it is. That's the little sensing transistor that picks up the voltage from the battery. And that's the first device driver that will eventually control the field voltage at the alternator. The lower the voltage in the battery, the higher the voltage to the alternator field to increase the output of the field. Now I'll flip it over and I'll show you what I've done so far. You see, I've soldered 2 of the 3 leads. And now I'll solder the 3rd one. Again, don't forget the heat sink. If you forget the heat sink, you're going to destroy the transistor from the soldering iron. So be sure and use a clip lead, an alligator clip lead or something. And what that does is that will draw off the heat from the wire you're going to solder, which is this one right here. This is the next one I'm going to solder, that one right there. So on the other side of the board, and don't lose track of it, flipping it around. That's easy to happen. Put your alligator clip on that lead. This will draw the heat off of the solid state device from the soldering process. I think this is still in the camera shot. I have to look, yes. Again, be careful. Make sure your tip is clean. See, it's been sitting now for a couple of minutes and it's already started to burn. Here we go. Soldering iron on and solder on at the same time. Quickly. If you miss it on the first shot, take a second shot at it and do it quickly. Here's the heat sink. There's no heat on this side now because this alligator clip has drawn the heat off of the lead. And these are the 3 leads now that I have soldered. And there's the device. Okay? Now, the next part of this, make sure you haven't lost these little sleeves. These are little insulators for the larger control. See these insulators? They have a tendency to slide off. Be sure you haven't lost any. Wipe the dust and dirt off of the board. And this is the mounting device and the heat sink for the power transistor. So I've wiped off the board and I've wiped this off. And now it's time to place that little mica washer here. And then we'll get the solid state device out, the power, which is here. These are also still available. The numbers have changed. And if you're on a project like this and you get stuck, let me know. And I'll help you find the numbers and the distributors. It changes from time to time and place to place. But anyway, I'll give you the current numbers. And many of these companies don't send invoices. So it's hard to know. But anyway, here are the power transistors, and this is the current number. Well, I guess you can't see it. Ain't that something? The camera won't pick that up. Well, anyway, it's a 2N6827. It's a 2N6827. Or I'm sorry, 6287. Dyslexia. 2N6287. And that translates to an ECG number, and I could look it up in this book. I'll look up that 2N and give you the ECG number. N60, what did I say? 6287. Okay, that'll take too long. Anyway, so how this goes on, now I'm supposed to have some of that heat sink for that white formula, which I don't have any right now. So I'm going to put this together without that. And I'm going to put this mica insulator on here. And then this unit has offset leads. They're just slightly above center. So you can't get this on incorrectly. There we go. Against the darker background, you can see the leads are slightly off center. So they will only go on the board one way. Now, this is something that you're going to come across. If you own a bus for 5 minutes, you're going to discover that new parts don't fit old screws. But guess what? Having these handy-dandy nut drivers around. By the way, this is a number 8. I suggest you buy a set of these nice quality. These are from Ace Hardware. I like these. These all have the standard colors for those sizes. The 5/16 is always yellow. That's one that'll fit your buses. This is a 1/4 inch. Those are always red. And you need the blue and the green ones. Those are the other two size. Those are the size that fits the nuts on your terminal boards. But anyway, once in a while we get lucky, and I found that I can self-thread this into the board. A little bit on each side. This is absolutely so good that it actually looks like it's supposed to be done this way. But what I've done is I've threaded that solid state device, this power transformer, with the current screws. And there you have it. And there are the two terminals. Whoops, I see I'm out of the camera range again. So what I did is I used my 1/4 inch screwdriver and turned the old screws down, and they threaded themselves into the solid state device, making that good solid connection. And now I'll solder those two terminals. Because of the situation here, this is designed to take a little bit of heat, and since you can't get anything on the leads to protect them, what I'll do is I'll go on the bottom side of the leads And I'll attach my heat sink. I'm going to tilt this camera up a little bit. I think maybe I get more light on the subject. And what I'll do is I'll stick this on the very end. See that? I'll stick that on the very end of the wire. I'll get an angle. See it hanging off of the end of the wire? And I'll solder it that way. Now I'll put the heat sink. After I wait a few seconds and let the heat draw off into the alligator clip, then I'll remove it from that terminal and put it on this terminal and solder this terminal. Just do it quickly. Don't leave the soldering tip on the device or you will burn it. Wait, make sure you're ready to do this before you do it. Okay. Now, the power transformer is soldered to the printed circuit board, the body of the solid state device, and the heat sink are matched. By the way, this heat sink was used in older units that had more components. They discovered that a greater current carrying capability of this device was cheaper than two devices sharing the current. Okay, now this project is finished and I'm going to assemble it into the voltage regulator device, and then in a week or so I'm going to take it over to the bus company and try it on our 4106, which is my test vehicle for doing alternator and voltage regulator repair work. So that's it. Thanks for watching. 73, 24, 88, and write if you get work and hang by your thumbs.